All right, I'm gonna go through this current project that I'm on. It's essentially a browser game, and it's multiplayer. It's a multiplayer 2D browser game, and it's essentially you're cubes and you fight each other, and it's a sort of like an FPS, but I didn't want to write an FPS. I wanted to write a 2D game because it's easier, it's one less dimension to deal with, and it's written in C. It uses OpenGL to draw 2D shapes, and I compile it with mscriptn, and I put it on the web. Compile it to WebAssembly. So the nice thing about it is that the client and the server are both written in C, and the client and server are connected through a WebSocket tunnel, and the server essentially handles the game loop. So in a client-server architecture, for like a multiplayer game, the client is essentially dumb. It doesn't actually do any computations. It essentially sends the key presses to the server. The server works out the physics, marches the game forward, and sends the positional data and stuff back. And this is good because it stops cheating. And it's bad because it introduces a lot of latency. And obviously, you fix all that issues by making the client not so dumb, but you keep the server authoritative, and that's the client server authoritative model. Both So the good thing about having the client and the server written in C, it doesn't matter if the client is compiled to the browser. They both communicate through a WebSocket. The good thing about having the client and server both in C is that you can write shared movement code and just import them in, like write a single header library. And right now, for the past couple of days, I've been writing the server, and the server is essentially it's a self-contained C application that it works with the front end. So all the front end would initiate a connection, pass in a token of authentication and a lobby key. And if the lobby doesn't exist, it creates a new lobby. If it doesn't exist, they'll put you in. And the server essentially sits in the background, accepting all these connections from all of these clients, iterating the game forward, and sending it back out. And what I wanted to do, what I wanted to use initially, is WebSocket. I tried all of these other things. You cannot use UDP in the browser. You can't. If you could use UDP, you would be in a whole lot of trouble, and you would open up the ability for websites to DDoS and all that stuff. So it wasn't allowed in the spec. UDP is allowed, however, on WebRTC, and that's for like audio and video streaming. But it is complicated, and it is not. It's not worth my time. It's really not. So I moved on to WebSocket, which is essentially TCP. The packets are ordered just like TCP, and it's like full duplex, so it's back and forth, and it's a keep alive connection, so it just stays on the line. So the client and server can send message that way, and the server can send a message back and forth, back and forth, back and forth, throughout the entirety of the game until the client disconnects. And I wanted to implement it in C, but that was until there was a time before I got to C. I wanted to write the WebSocket server in C++, and I chose C++ because look at all these libraries, and that was a mess because of the build process of C++. I don't understand the build system. I don't want to. I'm happy with just calling GCC, the space separated lists of all of my C files, and then loading them. Maybe I have a couple of single header libraries, but I will never use a complex build system like that. It takes too long. It's like, even if it's incremental compilation, it's still like, what, 5 seconds per compilation. I used a single header library that was C++. It took 10 seconds per compilation. It sucked, and I have a pretty fast computer. So, you know, and now I'm here. I'm writing the client, and I'm writing the server. And the server uses a libuv. This is the only library I'm using. Libuv is a event loop, and it'll essentially make all of this network programming asynchronous, and it'll all work fast. I won't have to be hard blocking. It's what I don't want to do. All right. So why am I here? I basically made an introduction to what I've been doing for the past couple of days, and this will give me right now. This will give me an opportunity to talk about how I write C and why I enjoy writing C so much. And it's mostly because of the patterns that I use. So if you go over to my blog here, I've written about this. I write C in a very specific way, and I've listed all of these things here. This is just a very broad list. It could be longer. It could be, in my head, it's essentially 3 times as long. But I've extracted that into these things here, and I'm going to run through the code and go through them. First, aesthetics and quality of life. I use snake case for everything. I hate these Pascal case and capital letter case at the front. I hate it. The most to me, the most readable thing is the most readable thing ever is just having these underscores. It makes everything so much easier to read. You don't need this or this. It's so much harder to read. So what I like to use is snake case, everything. And this also leads in to types. The POSIX way of naming their types is they have an underscore T at the end. I quite like it. I've grown to like it. But before that, I was actually using non-snake case for types, and this comes a lot from V because I've done a lot with V, and I really like how it has an opinionated approach to to code the syntax. So I either use one or the other, never both in the same project for obvious reasons. I also like to embrace simple variable names. Things like is upgrade, is WebSocket. These things I have sec WebSocket key sv means string view, which means it isn't a null terminated string. These variable names have to explain themselves. I mean, who's gonna? There's not enough time in the world to write all these comments. There's just not. There's no point. So you need to make the code explain itself. The perfect, most expressible program is one with no comments. That's the rule that I follow. So I try and make the code as expressive as possible, and I try and make the code, as simple as possible. Just simple variable names that explain the code. Another thing, reduce nesting. What I like to do is have these guard clauses here. If read equals 0, return. If read is less than 0, that's an error, return. Guard clauses. If pars is less than read, pars error, return. You don't need to have these big blocks where you have remove the return, else, dump everything in here and just nest. I mean, it seems obvious, but some people love to do all these nesting, and I don't like it. Let me pull in my new changes. Oh crap, hold on. I'll skip past this. All right, my password. All right, good. All right, now I'm back. Reduce nesting. I talked about it, and I'll talk about it again. Just try. Just try your hardest to reduce nesting as much as possible. You'll get creative. So you use these guard clauses. You would use goto at some points, and I'll get to goto later on. Extract things into functions. All of these things. I mean, the best way to do it is have these guard clauses. All right, now I'll move on. Here, goto. Goto is misunderstood, but powerful tool, and use it with caution. Okay, I've grown to like goto. It's nowadays it's people don't like it. Like a couple days ago, I had some code open. My teacher came around and he looked at it and he's like, "Oh, I don't like goto." I mean, obviously, because he's because it's essentially this thing that you get indoctrinated into. Like goto is bad, goto is bad, and yes, that's right. If you don't use structured control flow, if you don't know what an if statement is, don't even touch goto. What I like goto for is for localizing error handling code and flattening all this nesting. So what I like to do is one, reduce code duplication by using goto for error handling. So like this, go to response here, and and this falls through here, and only branch forwards with goto. This is very, very important. Why branch upwards when you have loops, right? Goto is used to just break immediately to the end. And it's not structured, no. But if I was making my own programming language, I would have something like this. I'd have label, open it like this, have some code, if, and then break hello. This isn't C, but this is just some alternative syntax where you can't misuse variables. Like you can't if all variables need to be defined, you can't misuse this. You can't access variables from outside the scope, which C doesn't like really care if you read from uninitialized data. It doesn't care, and it doesn't have these checks. So you're gonna run into some issues, which means use it with caution. Another one: embrace single header libraries. This is really really important, and this really it saves a lot of my sanity. I don't want to install libpng. I want to go online and download one file, include it, and get everything. And this is how I like to do things. So I don't like making new C files. If I'm just going to use something in one file, I'm going to extract it into a single header library, and that's that. So right here, I have this thing called wsutil, and what I have is my SHA-1 and base64 encode. So I implemented this a couple days ago. This took me 2 days. Well, 1 day. And what it does is it has functions for SHA-1 and base64 encoding. And what's nice about it is that it uses an STB style. And if you've never heard of STB, think of this: STB libraries. It's not how you spell libraries. Single header public domain libraries for C and C++. So this is the style that I like to emulate. And how it works is that you have an include guard at the top, so it's only allowed to be included once, and you have this thing here called you have this essentially this clause. So if def wsutil import. And if it's defined, it implements the functions. If it's not, it just gives you the definitions. And that's how I like to do single header libraries, and that's how they should be done. So I don't like linking because You can't. LTO is annoying, and I'd rather just get everything through a single header. And yeah, embrace simplicity on all levels. I mean, you're writing C. You don't have these traits and these dynamic dispatch, B tables. You don't have all of this stuff. You're in C, so you need to embrace simplicity on all levels, including build steps. How I build my project right now is essentially CD server, GCC, GCC, server, Pico HTTP parser, enter, done. And I have it. That's the server right now. And it's so easy. I don't need. I mean, maybe I'll make a make file, maybe, but I'm usually compiling from the command line with one single command. It's so easy and it's so simple. You don't need all this incremental builds and all these things. I just like having all my C files in one place and just using them. And it makes it so fast for me to iterate and write and understand the entire code base just by looking at it. Yeah, prefer libraries with only a handful, no more than 3C files that you can pull into your project. Now this is what I did with Pico HTTP parser. Here. So MIT license, and what it essentially is it parses HTTP requests. I originally was going to use something called HTTP underscore parser by the Node.js team, and it's just this huge C file, and you can link with it dynamically, and I just realized that why use that? Because it boasts no allocations, which is great, but it also has this weird callback system, which also adds complexity. And there's no closures, there's no lambdas in C, so you have to make all these functions and write all this code. And what I found is that if you just use Pico HTTP parser, you have to one write less code, and two don't have to worry about your dependencies. Yeah. So minor version, path, method, headers. I have space for 32 headers. Path, method, and headers. And it's just one call. phr underscore parse underscore request. And it returns the amount of bytes parsed. If it's less, it's an error, close, and return. And that's just so simple. That's I wish past me knew that, so I wouldn't have to go through all this shit. It took like a day, and I just realized that why worry with all these dependencies when you can just download one C file, one header file, and include the code that you need. So per libraries are the small, no more than 3, and you can pull them in your project. Alright, this leads into another thing. Write less code and use libraries with less code. And it kind of makes sense. Maybe the use libraries with less code makes less sense, but I'll explain. Writing less code is good. You're essentially expressing more with less, and that's something you should always strive for. You don't need all this bloat. And what I said before was I used HTTP underscore parser, and that required me to make at least 5 callback functions, which increased the code size, and it made everything annoying. I had to jump around. Everything wasn't localized. It was less expressive. So that's number 1. Write less code and prefer implementations that require you to write less code. And the second, use libraries with less code. Use smaller libraries. You don't need huge libraries, C++ dependencies, pull-in boost. You don't need this. You don't need it. And you may think that less code means more vulnerabilities. No, that's not the truth. Smaller libraries are easier to test. They're quicker to test. And they're usually fuzzed. They have this kind of special fuzzing. They're essentially hardened. Less code means less less room for vulnerabilities. I would always aspire to write less code because that's less code for me to check through. All right, this thing. Understand the C ABI on a spiritual level. Now, this goes into understanding how C gets compiled down to assembly and how the computers actually work, how they work. And this goes into the ABI, the calling convention, compilers in itself, optimisations, and everything. And what you can take from that is a couple things. One, operate on value types. What I often see people do is they don't like to return or use value types. So here, SHA-1 new, and it takes a SHA-1 context. Done. What you just did, essentially, is you forced the person to use a pointer, which incurs an overhead because you're writing to memory. And another is that you don't open this to optimizations. It just doesn't, because unless it's inlined, but it will most likely not be inlined. So this does not open to optimizations, and you may think that yes, passing in a pointer is great because it gives you more control. And I say, yeah, you could do this. You could do SHA-1 context pointer, context equals malloc, size of SHA-1 context. And you essentially get a pointer, and then you can do SHA-1 new context. And that works, right? No stack allocations except for the pointer. And you're essentially constructing the value inside the memory address. And yeah, that's a good thing. If you have a huge structure, sure, but this is literally, this isn't even that big. It's less than like 100 bytes. And what can happen is that I know I said function inlining doesn't happen very often, but it will happen here. This is a header only library. So that means the code is available to the compiler at all times. And what you could do is do this. SHA-1 context equals context, then context equals SHA-1 new. And what this will do, if you understand the ABI, you will understand that this does not get passed through registers. The return value gets passed as a pointer in the first argument, and it gets written to. So you can express this kind of malloc construct in the heap by function call thing without the need to pass a pointer. You can just do it like this: dereference context equals SHA-1 new, and one, the compiler will optimize it, and two, because of the ABI, the pointer will be passed in straight to malloc, and it essentially accomplishes the same thing, but less of this weirdness and all these things. Plus, most people won't even use the heap. I won't use the heap. I never use the heap. I do like static memory management. I try, but obviously when I'm using an event loop, lifetimes aren't really known. So I use malloc and free. But most of the time when I'm working on, let's say, a compiler and you need to allocate all these nodes, you just use a giant arena, a giant static arena. And I don't use the heap. And most good C programmers try to not use the heap. So you end up with code like this: SHA-1 new. Look at that, done. So easy. This is a value type, and this is a function call. And another good thing is that, let's say you have a structure. That's just a vector. And say vec3 contains x, y, z. And the size of this, 4 bytes, 4 bytes, 4 bytes. That's a size of 12. 12 is less than 16. and that means that it can be passed in. The function can be passed in through registers. I think it's RSI, RDI into the function, and be passed out through RAX and RDX. And you don't need to pass this huge pointer and start writing to memory. The whole thing is passed through registers. So it's very, very efficient. So you can just return vec3, add vec3a, vec3, vec3b, and one, it could probably get inlined, and two, this doesn't need any kind of memory accesses. This can all be done through registers, which is great. I don't even think this compiles to yeah. I don't even think this compiles to code like to a stack allocation. Turn vec3 a.x plus b.x a.y plus b.y a.z plus b.z. Okay. And, C opt3. Yeah. Alright, what code does it generate? On scalar time. Ah. My fault. Yeah. Look at that. Add PS, add PS. So no stack allocation. But let's say you have this. Wow, look at all of that. Okay, no, that's a bad example. But you know, Z, W. Anyway, what I'm trying to say is that when you write code like this, the compiler optimizes it out. You don't need to pass in pointers. You don't need to access memory. And if it gets inlined, even better. I mean, you could do it like this. Here. Vec3 add, void, vec pointer A, B, and then you can essentially do a.x, b.x, a.y, b.y, a.z, b.z. Oh, wait. Yep. Yep, and this incurs memory operations. So embrace value types. That's my advice. Yeah. Understand optimizations at play. Yeah, so I just showed this. You need to understand that value types can be passed through registers. How does it work? Greater than 16 bytes means it has to be passed as a pointer. How does return values work? All of these things. Alright. And the last one. Achieve perfection in expression. I think that C is the most expressive, it's the most expressive language. And many people agree, especially especially Zig and its creator, because Zig talks about no hidden control flow, all of these things, no dynamic, like no v tables, things like, you know, when you can look at a C function and you can understand exactly what it does. Is pointers, is this a value type, is this a pointer? In my opinion, it is the most expressive language. Nothing is hidden here. You know exactly what's going to be generated. You know exactly the optimizations at play. If you understand the C ABI, you can generally know how these things work. You can probably figure out what happens when they get inlined, and all of these things. You can understand what optimizations work, what don't. You can look at a code instantly. You can look at code instantly, figure out how it works. There's no There's no jumping out. There's no preemption, multitasking, fucking go routines. You don't. You look at code and you can just understand it, and that's what I like about C. Obviously, I could have explained that better, and I could have given better examples. But this code base is basically it's the nicest thing I've ever worked on in fucking weeks, and it's great because I work on a lot of V and all these things, and V is very expressive as well. It's not very complicated, and where where there isn't a lot of complexity, it it shows in the code. You can essentially do more with less, and that's perfection in expression. And it comes to two of these things: appreciate underlying implementations. So when you look at something like the WebSocket protocol, your first thing is your first thing that you would probably think is, what library can I install to run this, or things like that. And what I do, and what other C programmers or other just programmers in general should think is, when they see that, they should think, how does this work, right? The first thing I did when I figured out what WebSockets were is I went to Wikipedia, read all these things. I mean, I even asked ChatGPT to explain. I went to these websites. I read the RFC. I read all these things, and then I figured out I can use a library. And it's just that attitude of just figuring out how things work. Learn how these things work. That's what I always try and do. And if you know how these things work, you understand the limitations, and hey, you can maybe write your own implementation, which is what I've been doing for the past couple of days. You write your own thing, you know exactly what goes into it, you know its limitations, you know how powerful it is. You know, that's that's what I like. And if it's all in C, you know exactly what's in it. There's no hidden anything, no hidden control flow, and all of these things. And you know, that's why I like writing C. Why I've looked at all these other languages, and if I want to write something maintainable, if I want to write something where I have max control, where I know everything, and I know what goes in, I know I know what leaves, how these optimizations work, how the compiler generates code, how the ABI works, how functions get called, what's in registers, what isn't, what's in memory. I write C. And yeah, that's basically the gist of it. So aesthetics and quality of life, control flow, building and execution, understanding how C works, and achieving perfection in expression. Because C is the most expressive language there is. Alright, thank you. It's late, so I gotta get to bed. So, bye.